Smalltalk has a lot of different types of containers, so let's come back and look at them all, or at least all the ones that I showed you in this introduction, again. Our simplest, our most basic, was an ordered collection. And ordered collection is a bit of a mouthful of a name. It's named ordered collection because it's the base class of all of the collections that have an order, like arrays and lists do. But it isn't just the base class, it also implements an ordered collection, and specifically it implements a list. Well, how does a list work? Somewhere inside of this ordered collection, there are a bunch of nodes that have next fields, and those next fields point to the next node in the list, but we don't really need to care about how the list is stored underneath, only the fact that it is a list. So if, for example, I want to add something to the list, I don't have to add things of the same type. It doesn't know. I should use a string instead of a comment, though. This is a dynamically typed language, so you can mix and match if you'd like. I'm actually going to use fraction, because that will be more interesting. And now, if we display the ordered collection, it will happily show us 42, hello, and 3/4, all as part of that collection. An ordered collection lets you add things quite easily because you can add them to the end. I can also add it as the first element with add first. How'd I type that? With add first. So if I put add first 12 and then display again, we'll now see that 12 got added to the beginning. Of course, with a list, that is a very inexpensive thing to do. We can loop over the entire list with do. So I can print out a given value. I can print out all of the values. In this case, I will display 1 per line, but I already displayed the entire sort of string for the ordered collection. So we see this is what happens if you display an ordered collection. This is each element in the ordered collection. And you can get individual elements and remove elements. Generally speaking, removing from the front and the back, this being a list, is how you do a stack or a queue. So if I do remove first, how am I doing this? If I do remove first, and then display it again, now 12 has been removed. And in fact, let me remove this loop because it'll get confusing who's doing what. If I display what I removed, then you'll see the return from remove first is the element it returned, which makes lists very helpful for using as stacks or queues. You can add them with add and then remove first or remove last, depending on whether you're doing a stack or a queue, and remove first or remove last will actually return the value it removed. Now let's look at arrays. We can create an array with array new. So if I make an array of length 10, in this case I just reused the variable x, then I can display that array, and you'll see it's nil, 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 nil. There's nothing in the array other than nil. Nil is just our default value. It's like null. At is how you would get an element from an arbitrary position in an ordered collection. Same way for an array. In either case, you can also at put, but in the case of an array, that's much faster because, well, it's an array. So at position 1, I'm going to put hello. Then at position 3, I'm going to put world. Now if we display it, hello, nil, world, and all of the other nils are still there. And of course, all of my previous printouts of the ordered collection are still there because I haven't removed them. We can also define an array with an alternative syntax, which looks a bit like this. So I can define an array with 2, 4, and 6 in it, like this. You want to be a little bit careful when making arrays of numbers, because this is the number 2.4, and not 2 and then 4. Unfortunately, it uses dots to separate, and oh well, that's just how it is. And you can concatenate arrays with, of all choices, comma, remember, we saw in a previous video that you can actually name a method that looks like an operator anything you want, pretty much. You can't name it dot, because that's part of the syntax. You can't name it colon, because that's part of the syntax. But you can name it comma. So the designers of the array type just decided comma would be how you concatenate arrays, and also all other collections. So now, if we display this, we should have the hello, nil, world, all those nils, and then 2, 4, and 6. This concatenation does make a copy, so if I had another reference around to the original array, if I changed that, I would not see those changes in the concatenated version. Finally, strings are essentially arrays of characters, so if I do hello here, and x at 2, and let's go ahead and display that, then you'll see it displays E, which is indeed the second character in the string hello. The only reason why it's even worth mentioning that strings are arrays of characters is because of how you can use them. Well, I can't put in a string. It simply doesn't let me do that. $sign is the way that you do a character in Smalltalk. So if we do this, it'll simply complain. The object is read-only. Strings are all read-only. But I can take care of that. If I convert this string to an array using the asArray method on strings, now I can put that there if I want. If I display this as an array, well, it'll be a bit unsatisfying, because it's showing me there's a character H, a character X, a character L, a character L, a character O in an array. If I want it to actually look like a string, well, I have to make it a string again. So I convert it back to a string, and now I get the output I expected. It's fairly common to convert back and forth these various types. You can convert ordered collections to arrays, to strings, to arrays as you need. You shouldn't overdo it, but because they all have different strengths and weaknesses, well, that's why asArray and asString and asOrderedCollection indeed are methods on all of these types. You can easily convert back and forth as you need.